Hello, Tommy Gartlin here, Dundalk IT. Welcome back again. So this third video, we're going to just look at a little bit of a small program, the first program that we're going to upload to the Arduino Uno board, or upload to the microcontroller on the Arduino Uno board. And it might surprise you that as an electronic engineer that we actually write software, we write code, as well as build electronic circuits. So it's sort of it's an interesting job from that point of view. But we're not writing programs generally to run on PCs. We're writing programs to run on microcontrollers, which are part of electronic circuits. And it's very interesting, a very interesting area to work in. So the language we're using here is a version of the C programming language. It's actually C++. Within the Arduino IDE. Normally C is used, but the Arduino IDE makes life very easy to write programs very quickly by providing lots of functions, and a function is sort of a block of code. So it means that we don't have to get down to the very lowest level every time we want to write a program. It provides us with high level functions to use. So that might sound a little bit cryptic, but if you're interested in learning a little bit more about the language, you can go in here to the documentation, reference, and you can see here's the various functions that we can use. Okay, now those functions are sort of blocks of code, if you like. The basic C language is sort of here. Control, these are basic C commands, and these functions will be written up using these C commands. But that's probably a little bit too much information at this stage, but just to let you know that there is lots of information here on the Arduino site about the actual language itself. But I will explain what the various commands are on a need-to-know basis. So every good program, I would encourage people to always put some comments in, and a comment isn't really part of the code that's going to be executed. It's just information there to help you remember what you were doing in the first place, or maybe help other people to understand what the program is. And you can see when I start a line with // it means it tells the compiler, which is going to check this code and compile it down to effectively ones and zeros that can be uploaded to the microcontroller. It tells the compiler to ignore these comments, and it's not part of the code. So you can see I put in comments here, and you can put in lots of comments. You can put comments on a complete line, or you can even put comments at the end of lines. So they're just trying to help me explain to people what the program is about and remind me what when I wrote it and what it was for. So if, for example, there is no syntax errors in this code at the moment. You can see I'm just going to change something here. File preferences. I don't want to show verbose. I want the short version of the compilation. So that's what you will have by default. So you can see you just get 2 lines here, and it says everything is okay. It doesn't exactly say success, but it tells you how much of the program memory is being used up, 6%. And that's interesting, so you know how much program memory you've left when you upload it. But if I, for example, leave out those 2 lines there, you can see the color changes as well, which is helpful. And if I go to compile it, it says, you'd have to go back up. Always scroll back to the very first error. You see developed by Thomas Gartlin, and developed does not name a type, so it's very confused because it thinks developed is somehow there's supposed to be a command or something called developed, but obviously there's not, and so it's got confused. And I just want to show you what happens when there is an error. And it's always better to go back to the very first error, because you can see it's confused it, so it's complaining about other things that are actually okay. So that's what the / means. So anything after that is just ignored. I've got a counter here, and that's going to keep track of a number for me. And I've allocated some RAM space. Remember we said there was RAM in the microcontroller. So we've allocated 1 byte of RAM, and 1 byte is 8 bits. So I can't get into it in too much detail, but everything is stored in RAM, and we need to store a number. And we can use decimal numbers here, but internally it's stored in ones and zeros, the binary coding. And that doesn't concern us either, because we can use decimal numbers. But we do have to allocate a certain amount of memory for this number, and the more memory we allocate, the bigger this number can be. So suffice to say, with 1 byte, which is 8 bits, you can have a number from 0 to 255. Okay, so just remember that. Here is a very important command, serial.begin sets up our communication rate. Now before I get into that, you can see that there's 2 functions. There's a setup function, and that when I say begin and end, open squiggly bracket is the beginning of that function, and the end is down here, and you can see it actually conveniently highlights the corresponding ending bracket. So whenever they always come in pairs, like a pair of socks. Whenever there's an opening bracket, there must be a corresponding closing one. Okay, otherwise you have a problem. So here's the beginning of the function, here's the end of the function, and all these lines of code here are part of this function. Now the setup function is very important, as well as the loop function. You always pretty much have a setup function and a loop function in these Arduino programs. The setup function, the code inside the setup function, only gets executed once when you reset or when you power up. So it's only executed once. Whereas the code inside the loop function is executed forever, infinitely, so it's an infinite loop. There's the beginning of it, and there's the corresponding squiggly bracket, which is the end of it. So all this code is just going to be executed over and over again as long as power is applied to the board. When you switch off the power or restart, then you'll see this happen once, and then it'll fall into the loop function and continuously execute this over and over again. So that's why you always have a setup here and a loop function in the Arduino IDE programs. So the setup, you might want to do some things initially, only do them once, or send up some messages like I've done here, and then the loop function is where we take care of the main part of the system. So what am I doing in setup? I'm setting up a communication link. 9600 means 9600 bits per second. So you're all probably familiar with broadband speed at this stage, especially in COVID, and the importance of it. So that's the rate at which data can move across, wires, if you like. So we've got a USB cable, and we're saying we're going to have a communication rate of 9600 bits per second. And when we have that set up, and that's an agreement with the board, so the PC is also going to be communicating. So we have the PC communicating with the microcontroller, and they've agreed on this rate, 9600 bits per second. Remember, this program is running on the microcontroller. And then we have serial.println. We could do serial.print, which is just print it without a return at the end, and serial.println prints the line and then puts an enter. And when you print a message, a text message, then you have to have double quotes around it. And notice also I'm using round brackets, and it's very pedantic. So if you use squiggly brackets here instead of round brackets, then you'll have a syntax error. If you forget to have the semicolon, you'll have a syntax error. If you have a quote on one side but you leave out the quote on the other side, you'll have a syntax error. And what you should actually do is break it. Do that. Leave out the quote, leave out the semicolon, and just see what type of errors you get. And by that way, you'll understand that when you do get an error, you won't be panicked, because you'll know how to fix it maybe. Okay, and generally I only fix one error at a time. I go to the very top. If there's errors like this, I fix that, and then I just re-verify. So if I re-verify again, I fix that error up there. There's no problem. But if I left out that semicolon, for example, and re-verify, you can see now it's got a problem. Now sometimes the information that it gives you is helpful. For example, expected semicolon before serial, and notice how it highlights this line, but the error is actually on the line before it. And sometimes the errors, it just takes a little bit getting used to try and fix these errors. I would provide you with the programs. There will be no errors in them, hopefully, otherwise you can blame me. But then you can actually, try and edit the program yourself, but you'll always have a copy of the original program if something goes wrong, so don't worry about it. It's very important to experiment and try and learn that way. So that's the setup program, and here you can see I'm serial print, a message is in quotes, counter value is, and notice when I print out the actual counter, and that name has to be the same as this name here, and it's case sensitive, which means there's a difference between a capital C and a lower c. So if you've used lower c, lowercase letters for all the name, then you should use lowercase letters here, otherwise it won't recognize it. So here we're sort of saying there's such a thing as counter that exists. It's got a byte of RAM. So we're telling the compiler we've created this variable, it's called. So we create a variable. It's got initial value of 0, so that's just the initial value when it powers up or reset. Here we're printing out the value, and it prints by default in decimal format. And if you wanted to print it out in the actual native format of the microcontroller, which is binary, ones and zeros, then you can actually uncomment this and it will print that out as well. I've got a delay of 5000, and that's another function, delay, and that's 5000. It's milliseconds, so the parameter is in milliseconds, so that's actually 5 seconds. And then I counter equals counter plus 1. So this means we're changing the value of the counter to be the old value plus 1. So the counter was originally 0, we're adding on 1, so now the new value is 1. The next time we go around the loop, the counter was 1, add on 1, now it becomes 2. The next time we go around the loop, the counter will become 3, and so forth. So that's all we're doing, and we're just saying the counter value is, and we print the counter value, and then we change the counter value. So we compile that, hopefully, yes, it works. Then we upload it, and you can see here the progress bar, and that seems to work. And how do we see what's going on? We go Tools, Serial Monitor, and notice as well that on the serial monitor, which is the PC, the 9600, and in the program it's 9600. So the PC is communicating at 9600, and the microcontroller is sending information back at 9600. So here's the program running on the thing, and you can see the TX and the RX is sort of an indicator of communication on the USB cable. Okay, so the transmit and receive. And every time this is transmitting, so we're only transmitting data, and you can see every 5 seconds we're transmitting some data. And what am I transmitting here? Initially we send the message out, you can see that only appeared once, and now we're inside the loop and we're going around saying counter value is 0, 1, 2. So you can play around with this, very easy thing to play around with, change the messages, change the delay, increment by more than 1, increment by 2, or increment by 3. And you'll see that if it does get to 255, and it can run very quickly. So say I said, just as a matter of interest, say 100 milliseconds, that's 10 times a second. Computers can run really, really fast. And that's one of the advantages they have over human beings. You can see, we hope up the serial monitor, and you can see now, look how much quicker it's going. What happens when it gets to 255? It'll just wrap around because there's only 1 byte of memory allocated to this variable. And the maximum value it can store, when all the bits are, all 8 bits of the byte are all 1s, it just wraps around back to all 0s again. So when it gets to 255, it'll wrap around to all 0s, and there you go. That's the significance of only allocating 1 byte. The next size up would be an integer, which would be 16 bits, and then we could have much bigger numbers. But that's getting a little bit more detail than probably you need at this stage. Okay, so as I said, that's the first program. It's a very important program in some ways because we introduced this serial print command. This allows us to see what's happening inside the microcontroller because it can communicate with us, and we can send information back to the PC where we can view it. So if, for example, we had sensors connected to the pins in the microcontroller could read those sensor values, but then it could send that information to the PC so that we could view the sensor value and therefore know that our circuitry is working correctly. Okay, so at the moment we don't have any components connected, but later on we will have. And it gets more interesting when we have electronic components and some software running at the same time to make a complete system. Okay, so thank you for listening, and we'll see you again soon. Bye now.